So tangent is created by dividing sine over cosine. Keep in mind this point is just a regular old point on the coordinate plane, and that point is 1, 0. Okay? So if I try to figure out what tangent is sine over cosine. So sine over cosine, or y over x, is 0 over 1, which is 0. But to create the pair, to create the coordinate pair for tangent, I'm not going to look at this. I'm going to look at inputting the angle of 0 and outputting the value for tangent of 0. So the first point for tangent is 0, 0. For the next one, I would input pi over 6, and I would output 3 over 3, and that comes from dividing the sine and cosine values. I would input pi over 4, I'd input 1. In this case, the sine and cosine values are both the same, so it makes sense that that is 1. I'd input pi over 3, I would output root 3, which is, this is the sine, this is the cosine value. I would input pi over 2. Remember, this point is 0, 1, so it would become 1, 0, but again, I don't want to look at that. I want to look at inputting pi over 2 and outputting undefined. So a couple of things here. If you don't know how I got these values, they are included in my first video on the unit circle. They are simply calculations from, they're really calculations from geometry and rational equations from Algebra 2. These values I've typed into the calculator here because we have some new irrational values. And undefined, remember from the rationals chapter of Algebra 2, is an asymptote. So we focus here again on 0, asymptote, 0. We have another asymptote here and then back to 0. And these values we're simply going to graph as pi over 6 and 0.577, pi over 4 and 1, and pi over 3, and then in this case 1.73, and then an asymptote. So you can see those points right here. I start at 0. I then have a value at pi over 6 of 0.577, and then at pi over 4, I'm at 1, and then at pi over 3, I'm at root 3, which is 1.77, and then an asymptote at pi over 2. And then, again, that mnemonic device, it's so important. All students take calculus, so all values are positive here, including tangent, but only sine. So notice tangent is negative. And then tangent is positive. Notice the values are positive. And then cosine is positive, so tangents are negative. Please keep in mind also that tangent is understood as the slope of the hypotenuse of those special right triangles. So these special right triangles have a positive hypotenuse or positive slope value. These have a negative hypotenuse or negative slope value. And notice that these values, they correlate because they're the same line, right? They're the same line. So this is negative. These are both negative. These are both negative. These are both positive, 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 0, undefined. They are the same line and therefore have the same tangent or slope value. So going back to this, we're at the asymptote. Then we're going to have negative values below the x-axis. Then we're going to go back to 0 and have positive values. And then we're going to have an asymptote at 3 pi over 2. And then we're going to go negative again. And you can see that right here. Negative values at pi, we're at 0. Then we go back up. Then we have an asymptote at 3 pi over 2. And then we have values here that are negative and then go back up to 0 at 2 pi. And the parent function values for that, I like to think of it as 0, 0, asymptote, 0, asymptote, 0. And then we do need at least one value to show the curve. And so we use the pi over 4 values, all of them 1, negative 1, 1, negative 1. So when I graph this, I graph it like this. 0, asymptote, 0, asymptote, 0, 1, negative 1, 1, negative 1, and then I show the curve that does sort of resemble a x to the third power or cube graph. So now let's talk about the interesting domains and ranges for tangent. The range, fairly simple. Negative infinity to infinity. It looks kind of weird. It does have these asymptotes, but that does not affect the range. But when you talk about the domain, first thing I want you to notice is that the graph does keep going. So it does go this way, and it does go this way due to the coterminal and negative rotational angles from the unit circle. But notice that if you look at the unit circle, tangent completes all of its values, 0, positive, 0, undefined, negative, 0. It does it in pi, not in 2 pi. So you can clearly see that between these two asymptotes here, from pi over 2 to 3 pi over 2, you have 1 pi, and that represents, again, that actually represents from here, right, starts here, represents from here to here, that's half the unit circle. So its period is pi, not 2 pi, okay? And that repeats, again, it would also repeat here, and then it would keep going. And so it does have a domain that keeps going, but it's interrupted by these asymptotes. And you might have already looked like, whoa, what is that super long domain? It's actually a review of multiple concepts going all the way back to Algebra 1. So let's talk about it step by step. The first thing is x, such that x is a real number. So we know that all the domain x values are real numbers, okay? But then we have these exceptions at pi over 2 and 3 pi over 2. And if this was Algebra 2 class and we were talking about asymptotes when we saw them in either in logarithms and exponentials or in the rational functions chapter, we would simply say the domain is all real numbers except x cannot equal 1 or 3. And so you can start to see that here. So where in the world did this come from? This actually is a review from the chapter on sequences and series. So I have a little demonstration of how this happens. So as you see, we have on this graph, we have asymptotes at 1, 3, there'd be another one at 5, and there'd also be ones at -1, -3, and -5. So if I take a look at that, I have 1, 3, 5, 7, and so on. So if I look at that, if I take that sequence of 1, 3, 5, and 7, and I apply the equation for arithmetic sequences, plugging in 1 and the common difference being 2, and I distribute and simplify, I end up getting the value, the equation -1 plus 2n. And that is the equation you see that I have put in here. It's actually reversed in this just because that's the way that trigonometry writes it. So for sequences of series, this would again be -1 plus 2n, but here we have 2n minus 1, and then pi over 2. So as you can see, this is saying odd pi over 2 values. This is mathematically saying odd from sequences and series, and then we have pi over 2. And the last problem is, well, what is n? N means number. So then we say, well, n is actually an integer, meaning n is actually 1 or 2 or 3 or 5 or 7 or 0. If I put any of those in there, I would have an asymptote. If I put 0 in there, I'd have negative pi over 2. If I put 3 in there, I would have 6 minus 1 or 5 pi over 2, the one that's over here. You can actually simplify this a little bit by simply putting z there, and this is traditionally what you see is someone will just combine those two and say x, such that x is a real number, but x is not equal to odd integer values of pi over 2. And I know that looks complicated, but if you would rather just write it out and say all real numbers except odd pi over 2 values, that would be a great start, and then you can try to piece this together one piece at a time. All right, I hope you have enjoyed this video, and I hope it has helped you with understanding how to graph graphs and use the unit circle to make parent functions for sine, cosine, and tangent.